I was anticipating a different John to introduce me. I was actually anticipating John Ober. And it was kind of funny because John Ober was the engineer that actually hired me on with TxDOT. And so I put together a little story, I thought of a little story to connect with John Ober. I'll still tell it even though I actually don't. Oh, he's back there in the back. So appreciate you hiring me on, John, about 10 years ago. But early on in my career, John was the area engineer at the Bell County area office. And maybe a couple of years in or so, we had a bridge that got hit and under construction that got hit. And John, actually, I guess because I was young, I don't know, took me out with him to investigate what had happened. And so I hopped in the truck with John and we're headed out there, making sure all the advanced warning signs are posted and the clearance signs on the bridge are posted. I actually had an overheight detection system for this bridge under construction because we had some low clearances that, you know, if an overheight vehicle came through, the signals would go off to allow them to exit. And so we drive up to the side, everything checked out, everything was working. So John gets out, we both get out of the truck, and John tells me to hang back, and he's going to go talk to the police officers there and the person who had hit the bridge. And so I see John up there, and he's talking very agitatedly, and you know, I'm paying attention, trying to figure out, you know, how do we handle things. And he's very agitated, seems very upset, and all of a sudden I see him calm down, and I think, well, that's strange. And so I see him start shaking his head and smiling, and everything's good. And so he comes back to the truck, and I said, well, John, you seem very agitated at first, but when you came, you know, now you seem very happy. And he goes, oh, they let me know they didn't hit the bridge, they were delivering the bridge. So actually, you know, it's kind of funny, finding a bridge joke is not easy. So it took me a while to find that one, and I see John switched moderator duties because I guess last year I told a bridge with the person that introduced me, Andy Petter. And so I guess John thought if he switched that I wouldn't tell a joke at his expense, but I still did it. So I guess next year if they ask me, nobody will introduce me, I'll have to introduce myself. But anyways, I'm very appreciative of John hiring me on, and actually of Kirk bringing me to the Waco area office for this project. It's a very unique project, and I really appreciate the opportunity to get to be a part of this project. As I was thinking about this presentation and just what I wanted to talk about, I wanted to tell the story of the Brazos River Bridges. And as I was thinking about the story of the Brazos River Bridges, it really hit me that this bridge has a lot of parallels with our engineering careers. A lot of the lessons that we can learn. I learned a lot of lessons through this bridge, and I want to share those with you. Just like our careers, all of us are very unique. This is actually a very unique bridge. This is the first Extratus bridge in the state of Texas. There is a couple other in the states, and it has been, I guess, came about overseas mainly, used overseas. And it's actually the first steel composite bridge, Extratus steel composite bridge in the United States. And then also just some of the aesthetics that we wanted. This is the city of Waco. Baylor really wanted a signature bridge in this area. And so some of the aesthetic things, the lighting is very unique also to accent this bridge. But just like all of us, we have to start in a location. Our project site is right there, right over the Brazos River Bridge near downtown Waco. As you can see here, the location had discontinuous frontage roads, U-turns at the river, and so needed to connect those frontage roads. This location is very unique in that it's a very busy river area. As you can see up here in the picture on the right, the new McLean Stadium is starting construction. So that was in our northeast corner. On the northwest corner there we have the Encore substation and a restaurant, Buzzard Billy's. The southwest corner we have Baylor Robinson Tower, a lot of pedestrian traffic, students coming back and forth there. And then on the southeast corner there we have the Texas Ranger Museum, an active Texas Ranger outfit, and a visitor center. And so just like in our careers, it takes a lot of communication, a lot of people to work together to implement projects well. And so there was a lot of coordination here between us to work together to get this. And just like all of us, we need to have things that have come before us and things that come after us. Similar steel girder composite Stratus Bridge built recently in Vancouver, Canada, the Golden Ears Bridge. And then the Pearl Harbor Memorial Bridge in New Haven, Connecticut is currently under construction. An Stratus Bridge is basically a combination bridge. It's a combination between a girder bridge and a suspension or cable stayed bridge. A girder bridge is what we're most familiar with. The girders span the river or the roadway that we're crossing, whatever we're crossing, and support all the load. In a suspension bridge, you have your cables that basically have your vertical support or bearing the load. An Stratus Bridge is a bridge where both are carrying the load, both the cables and the girders. The load is shared, and the stays act more like pulling the girder together and strengthening those girders. And this bridge was chosen as a signature bridge for Waco, and the reason that they chose the aesthetics of it was that there's a suspension bridge that's actually a pedestrian bridge that used to be a vehicular bridge in Waco. And so in order to cooperate with the community, Bridge Division and AECOM came together with this idea of the Stratus to give that cabled look, but because of the width of the river, being a shorter river, not big a span, we couldn't do a true suspension bridge. You see here, true cable stay bridge, cable stay bridge, suspension bridge. You have a very high pylon in comparison to the length of the bridge, and your girders are very shallow in comparison to the length of the bridge, as opposed to Stratus Bridge, which we have much shorter pylon and much deeper girder to carry the load. This bridge here was planned to have 3 lanes in each direction to connect those frontage roads, and also to provide better storage exit ramps. We changed our ramp configuration there. You can see in the picture there on the right, we have a very short exit ramp on the top right to get to the stadium. This bridge is 56.5 foot wide. It was northbound and southbound frontage road bridges, 56.5 foot wide, 620 feet long. From pylon to pylon is 250 feet, and then from the abutment to the pylons, it's about 3/4 of that length, 185 feet. Here's the typical section: 3 lanes, 2 12-foot lanes, 14-foot lane, 10.5 foot sidewalk. There's anticipate a high volume of pedestrian traffic. We wanted to provide a good place for pedestrians to cross to get across the river. And just like our careers, we all need a good foundation. And so the first step in building this bridge was our drill shafts. These are actually there in the river. You can see the pictures there of them drilling the river with their rebar cages ready to go. These are 10-foot diameter drill shafts to support the bridge. After we got our drill shafts, this is actually where I came on the project about the time frame. The previous project manager, Jacob Bell, who did a great job of getting this project going and started, took another job, and I came on at about this time when the footings were being done. These footings basically are right below the water level and transferred the load from our 9x9 pylons to our 10-foot drill shafts. And this was actually my first time to do a bridge in the water. Came on right as they were doing this. We had our form set in the water. Unfortunately, we're having a little bit of leaking problems, so coordinating with the contractor, we came up with some methods to pour this underwater, even though, or some water, even though it was supposed to be a dry pour. Got with Bridge Division, invaluable resource to see how we could do that, ideas from the contractor. And basically, we forced the water away from, we started in one corner and forced the water into pumps away from the concrete. And, just like in life, a lot of times we're faced with some difficulties. Things don't always go exactly as we had planned. So the first footing pour, I'm out there, and it's a brand new engineer, and we're having, I guess, some learning curve that we're going through as a contractor, and I'm out there watching the pour, and so I think it's important in our careers too, lesson that I learned, to have higher power that you can rely on. I remember being out there on the footing pour, and as we have water, and trying to prevent that from, or watch and make sure it doesn't mix too much with the concrete. It started getting to where I was starting to question it, and I started really praying that there would be very clear whether or not I should make the call to cut off this pour or not. And actually, our pumps went down completely, and the water mixed, and so it became very clear. But we learned a lot of lessons, and I think that in life, in our careers, when something goes wrong, we learn from those. We learn what went wrong. The contractor did a great job of coming up with some different ideas. They brought in some different pumps. They brought in, actually, you can see those buckets there. They put a bunch of holes in the bottom of those buckets to prevent things from getting up into your tube there. And actually got some divers out there and sealed it a little better. I mean, we still had to deal with the water, but had a success there pouring those footings. And then as each footing came, we got better and better and better, and were able to do some of those without any water coming in, very little. After we got through with our foundation, the pylons were the next step. And you see here the 9x9 with the aesthetic features there on the right side of the area. And these pylons are about 1/7 of the length of the bridge, or for the cables. Here's just a couple pictures of the pylons being constructed. Obviously, this construction much easier once you get out of the water. It's pretty simple. You get your forms, everything. It's a lot more simple. Just the abutment there being built more on the pylons. And so after that came in the girders and the floor beams. This is our typical section for our girders. The depth of our girder here is about 1/38 of the length. And here's just pictures of them being fabricated at Hirschfield Industries. Just another picture there of that. And just like in our careers, another lesson learned that we all need to know is we all have to have a plan. Planned, in this case, from abutment 1 to abutment 4. AECOM did a great job of detailing that out in the plans. And then Lane did a great job of taking that, putting that together how they wanted, and submitting that to AECOM. But basically, we have shoring towers that we set from the abutment to the shoring tower, from the shoring tower to the pylon, and then coming from the other way and setting it in the middle. And so you can see here, setting the girders, our shoring towers. And then another great lesson, we had to meet in the middle. We sat the last piece there in the middle, and had to make sure that all fit together well. Set that in there. And then the next step is the actual stays. And so the anchors are connected to the girder on one end, and then we have a saddle that they will go through to provide that additional support. You see some of the loading there on the anchor system. There's what the anchors look like. They were connected, bolted onto the girders. And then the saddles were formed in the pylons. This was actually a patented system to where we could, each of the strands could be individually installed or replaced, which helped to reduce corrosion and fatigue, and also just if there's any future maintenance, being able to come in there and replace those if necessary. Here's our saddles that would be being produced by Fresnay. And these saddles were actually set on the ground in the rebar cages, staged there, and then lifted on top of the pylons. You can see over there on the left one of the rebar cages with the saddles in it. It was very important that we got those saddles at the very exact directions, both in the X, Y, and Z, rotationally, because those cables had to pull a very particular way. And so coordination between Fresnay and Lane, and as they did the deck pours and everything. Here's the form up there ready to pour on the saddles. And then we had a very particular construction sequence. In order to do this, to stress the cables and pour the deck at the same time, it was a very particular process. We poured first at the pylons, stress cables, continued to pour, stress cables again, finished our pour and stressed the cables, and then tested those cables and came back and restressed a couple of them and made sure they met the models. You see here the pictures of the deck pours there at the pylons. Then our stay cables, there was a single plane of 5 cables at each pylon, and all those stays consisted of 12.62-inch diameter strands to support that. Another lesson learned, I mean, if you think of yourself as the girder, you're going to need people around you that are going to support you, that are going to help you through your career. And I've been fortunate enough to get a lot of that help and guidance and support. From the pylon to the first set of cables there is about an 1/18 of the length of the bridge. And then the total distance between the first and the last stay cable is 1/4 of the length of the bridge. You can see here the cable stays being constructed just as they keep going, and continue to do those. And so they did them in a very particular process and stressed them. They installed them all, and then they were stressing and pouring, but putting them on there and getting them, and they're not all totally straight in line. It kind of has a little bit of a fan due to the way that they had to go attached to the anchors there. Right now, where we're at, we have it totally open for traffic. We still have some lighting and some aesthetic things left to do. This bridge was actually part of a larger contract that we let in September. Well, we let it in September of 2011, and the construction on the bridge began in fall of 2012. We opened the bridge 2 months earlier than anticipated. We had some incentives in there. We change ordered those incentives actually in there because of McLean Stadium coming and when their first game was going to be. And so in order to make that, we added that, and Lane did a great job, our contractor, of meeting those deadlines and getting that roadway opened in time for that first game. And here is, as you can see there in the background, McLean Stadium. And just a picture of the bridges and the stadium together there on game day, fully open for traffic. You can see we're still working on some of the sidewalks below. We still have our lighting to go. And so in our careers, I think it's important that as we do projects, we think about where we were and where we wanted to be, go back and check and see. And Jody did a great job of, our PIO from Waco, of putting this slide together of what we were intending for it to look like, and then transitioning in what it turned out. And so a successful project where we got to where we were trying to go. A chance about that, and from a different angle. And we put the stadium in the background on this one so that it wouldn't dwarf our bridge here. You can see there, very similar to where we were trying to get. And then it's nice to take a minute after a successful project and sit back and enjoy that project. Take a minute. I have a time-lapse video here. Unfortunately, in the embedded file in the PowerPoint, it wasn't working very well, so we'll watch it on this MP4. It'll flow better. But you can see there our pylons and our footings going in on both sides of the river, coming up, continuing with our pylons. We should be having our girders coming in here on the southbound side and now the northbound side. We've got our floor beams going in there, construction going. And here we'll start deck pours over there on the northbound bridge, pouring at the pylons. The cables will start going in there on the northbound bridge, pouring going on the southbound bridge at the pylons. The cables going in there, tensioning. Continuing to the construction sequence to pour the rest of the deck. And you see here we open traffic. We have them push from side to side as we do some rail work and as we do some sidewalk work. And as the project progresses, we're moving them back and forth. But you can see here near the end of May, early June, we're starting to get it completely open. Traffic is flowing across there, ready for game day. And so a successful project for the community to get that ready and in time. And then sometimes after you've had a chance to sit back and relax, we need to evaluate how well it worked. And so, in coordination with City of Waco and Baylor, plans were put together on how to handle not only the vehicular traffic but the pedestrian traffic coming to the stadium site. And so plans were put together on what we had available for coming there. You can see here our main routes coming in, I-35, Business 77 or LaSalle, and Highway 6. And then we actually had a project right in front of the stadium, which we converted MLK into Loop 574 to provide additional access there in front of the stadium, which Lane Construction also did and got done in time for the stadium to be open. And you see here very high volumes anticipated for the pedestrians. Working with Baylor and through this whole project, it was we had coordination meetings between ourselves and Baylor on the stadium. When we were going to have lanes closed, when they needed to get in and out and everything, and worked out well. But just a large volume of pedestrian traffic coming and leaving the stadium, and just planning for that. And then our traffic volumes, I know they're really hard to see on there, but large traffic volumes coming in on each of the different routes. And then just getting out messages to the public on game day, where to go, where to park, what's closed, how to get to different places, information to make sure that flowed well, using our variable message signs. And then sign locations, temporary sign locations that described where all the parking was, make sure that our facility that we built in conjunction with our other routes would work well for this. And then just traffic leaving the stadium. And then departure, giving people information how to get out, what's closed, what's open, coordinating that. And then I think what's also important is to take a chance to say thank you to those that have really helped you, that made the project a success. First, I got to thank AECOM and Jody Wheatley for their assistance on this PowerPoint slide. I borrowed or got permission and borrowed a lot of the technical things from AECOM's presentation to the Steel Council on this bridge, and then pictures and stuff Jody put together for me and pulled that together. TxDOT, working with the City of Waco and Baylor to provide a bridge that the community wanted. Designer AECOM, who we had on construction services to help us through the process as problems came up to redesign things and look at those. The contractor, Lane Construction, who did a great job of getting this bridge built on time. Finley Engineering Group, working with Hirschfield and Fresnay on our cables and our girders and getting that all coordinated. And then really the real thanks goes out to the people who built the bridge. The workers there from Lane Construction, our inspectors, the staff for Lane and for TxDOT that were involved in this project. And special thanks really go out to, from me, the inspectors that we had out there that made sure this bridge got built the way it was supposed to be built. Out of the area office, and we actually had 2 area offices participating in this, just Hillsborough loaned us an inspector just due to workload, but Lawrence Wilson out of the Waco area office and Guy Wardlow out of the Hillsborough area office And then the invaluable resource from our Bridge Division Inspector, Stan Ybarra, who came down and inspected all of our steel structures. Just a great asset and just a great knowledgeable person. And so